I'm Gary, Chief Engineer for Quality Air Management. I'm here to introduce you to a unique concept of dust collection, the ultra-flow dust collector. What's unique about it is that we can do the same capacity, the same job any other dust collector does, but with 40% smaller dust collector and half the dust filters in the unit. How do we do that? That's what I'm going to explain to you. This is technology that's been around for 25 years or more, but in Canada it is brand new. We're the first ones to introduce it here, and we're also reached the 6th generation of evolution in this technology. All other versions of this technology is still stuck at the 2nd generation. Some of the features that we're going to be looking at, for instance, is the valves up here that feed the compressed air into the pulse pipes, which create the pulse jet, which cleans the filters out. This is a self-cleaning dust collector. Those valves and that header that you see there are designed to be 125% more than the capacity we need for cleaning. That is important because it ensures that we will not fall short, or if the air line to the dust collector should for some reason fall a bit, we can compensate for it. One of the features we have is this little filter here on the magnehelic line. This magnehelic measures the pressure across the dust collector and gives you an indication of the condition of the filters. Because our cleaning system is so powerful, we have to put that filter in here, because with the power of the cleaning, we could send some dust back down through this line and clog up the gauge. So we put the filter in to prevent that. Nobody else does that because their cleaning system is just not powerful enough and it's not required. But ours, we have to have. Another feature here is our control scheme. You'll notice that we do not have a pilot valve assembly in here, where you have the electrical system going to the pilot valves, and those pilot valves feeding pneumatic lines to the valves. That we've done away with, because it's just one more item that can go wrong and be defective at any time, so we've eliminated it. We directly connect to the control panel and do everything electronically. On this model, we have an optional explosion vent. Because this is going into a grain dust application, it is required by code. And so that's what our explosion vents look like. They're very simple compared to many out there, and much more reliable than some of the rupture disc explosion vents that are around. Now, this is the inlet and the outlet of the dust collector. We're going to go up there in a few minutes and see some of the features up there. But right now I want to concentrate on this inlet. Most dust collectors have an inlet going into a hopper. Now, by the way, this dust collector is a bin vent. There's no hopper. Normally there's a pyramid hopper under here and legs that raise this unit up. This model does not have that. But normally you'll see every other dust collector has an inlet going into the hopper, and the air is coming up through the dust collector and out the outlet. And that's why they can only run at 1-to-1 air to cloth ratio, up to 8-to-1 when they're really being aggressive on a heavy dust. Our dust collectors run at 18-to-1 regardless of the application. And I'm going to repeat that because you've not seen that before. We run at 18-to-1 on all applications. I don't care what you throw at it. And the reason for that is because we have an inlet up here. It's a high inlet, and it's a large inlet, and it leads into this chamber in here. It's a dropout chamber and distribution chamber at the same time. That's two functions. The large inlet allows the dust and air to enter slowly, and then it distributes completely across down through the depth of this chamber. The heavy dust will drop immediately down to the hopper and never go into the filters. The light dust will go through this perforated baffle, which is very important in this unit. The baffle distributes the air across all the filters, so it doesn't all come in and cram into these first filters. It's going to go depth-wise into all of the filters. But also, you'll notice that this is a perforated baffle, not a solid baffle. Extremely important. And the perforations, the amount of area, open area, and the type of perforations is critical for this thing to work properly. What we want to do is create enough air to go through the baffle into the filters, and the rest of it going down to the hopper. There's a very critical ratio between what is allowed to go underneath and what goes across. So that the net effect is that the air sweeps across and down towards the hopper. And that is what allows us to run at 18:1, because we're continually cleaning the filters and dropping it to the hopper. We're not hanging anything up here by upward flow. Now, you saw earlier the perforated baffle. Now we'll come back to the inlet, because I want to show something, another factor that is very important. You'll recall I mentioned the large inlet, and that slows down the air coming into the dust collector. It enters the dust collector and goes into this distribution chamber here. And you'll see how deep that is. It goes the full length of the dust collector. And you've got perforated baffle here that forces the air to go down to the bottom of the dust collector. Instead of all cramming right here and going to these filters, it's forced to go down. But it also has another effect, is that the heavy dust that's coming in here will hit the baffle, or just by inertia will drop down straight to the hopper, and only the light dust will go with the air across the baffle and into the filters. The net effect is that the air has that net flow down that I mentioned earlier. This is the outlet of the dust collector. It shows the cleaning system, where the filters go in, and it's also the clean air plenum. We install the filters through these holes in the tube sheet. It is a top-loading collector where you would access it through these access doors, and you would easily remove. There's just one bolt to remove there, and you can remove the pulse pipe. Then you just drop the filters in. That avoids you from having to deal with the dirty, mucky air that's down in the dirty air plenum. You just pull the filters out. The worker does not have to worry about air quality or breathing in that stuff when he's out here. We have some very important features here to show. The bag, for instance, is similar to a standard bag with a disc on the bottom, but we add a cord seal gasket right here. And you can see the thickness here. And that marries up with the cage, which has a groove here for this cord to fit into like so. Now that is very important, because that's what creates the seal on here. But also we use an orifice plate, which you see here. And that screws down onto one of these holes like this, and on top of the cage like so. And it has two functions, very important for this technology. It squeezes down onto the filter cage, onto the gasket, and creates a 100% positive seal here. Most dust collectors are loosey-goosey, and they will actually leak dust from the dirty side onto the clean side. And once your pulses that down in there, you start dirtying the inside of the filter, which causes it to clog and reduce its life by quite a few times. We avoid that by having this system here. Now, the cleaning system, the other function of this orifice plate, you'll see the opening here. This opening, depending on how long the filters are, is critically designed to give us just the amount of velocity through this inlet and the amount of air, the volume of air that is generated by these nozzles here that are connected to the pulse pipe, that are connected to the valve here. Okay? Now, in this technology, you'll notice we've got nozzles here. It's not just a plain orifice on the pulse pipe. These are specifically designed as supersonic nozzles that increase the cleaning power of this pulse by 16 times over anything else that is out there. And by combining that with this orifice plate and that opening size, we can generate more power at a lesser volume, and I'll explain the volume, at lesser speed, sorry, than anything else out there. The airspeed is important because as you pressurize this bag to clean it, the air is going to expel like this. So it's going to be going from this bag here over to this bag here. And if you have too much airspeed, it's going to collide onto the other bag and cause dust to puff through while it's filtering. And that's why most baghouse dust collectors cannot be used for recirculating air, because they're just not efficient enough. With ours, we have a low speed going across, so the dust will carry over to about here, then drop to the hopper, never gets to the adjoining filter. And that is very important, because that way you never cause dust penetration through to the filtering bag filter. And so we have 99% efficiency, virtually equivalent to a HEPA-type efficiency that you cannot get with any other dust collector. So that's basically all the features in a major way. There's a lot of little details and everything, but it'll take me a week to explain all this stuff for you. So we're going to leave it at that. I think you've got enough to be convinced that this is a unique dust collector, and we feel is the best one on the market at this time. So this is the UltraFlow Advanced Technology Dust Collector. Although it's been around for 25 plus years and has proven itself in thousands of installations around the world, it is still relatively unknown, and likely you will not come across it unless we introduce you to this dust collector. It's new to Canada. We're the only ones who produce it in Canada. We're also the only ones who produce the 6th generation of this technology in the United States. Most other people who do this technology are around the 2nd generation. So we are very exclusive when it comes to this dust collector.